Hello everybody. Today we are going to be quickly going over Karnaugh maps. I'm going to try to do in 15 minutes. See if we can accomplish that. So Karnaugh maps, that name does sound like a Russian guy who'll kill me and you, but it's actually a American physicist, mathematician, computer scientist who made them. And the whole point of Karnaugh maps is to simplify expressions. What expression is Boolean? I think it's like Boolean. All right. Now, how does it simplify it and how do you use them? Now, this first one is a two variable. So how do you do a two variable? First, you want to make a line at an angle. And what you want to do is read this from left to right. So reading this from left, I got x and y. Right? Now making my square, just do a little square like this. And there you go. And inside this little square, all I got. Now my y's, what inputs can I get from my y? Just 0 and 1, right? And my x, I can only get 0 and 1. You can't write it like 1, 0. You always want to go in numerical order, so from 0 to 1. And this goes downwards in numerical, and this one goes to the right in numerical. All right, now doing this, you want to draw your little two lines that are as ugly as mine. All right, and the way you want to read it is, well, 0, 0. This gives me 0. So 0, 0, that's the common box. Gives me 0. Right? I'm going to put the arrow. Actually, let me delete this so it doesn't confuse y'all. There you go. Then my x is 0, my y is 1. My x is 0, my y is 1. And that gives me 0. Then there's 1, 1. And that's these two inputs, right? Oops. So 1 and 1. How do you do this? So what you want to do is select your 2 to the n big box, and so your 2 to the n, which means is you're either 2 4 8 16 and so on, right? Dot dot dot. And so what does this mean? You want to select the ones, so you see these ones, but you can only make a box of combo of 2's. So you see this is 2 ones within the same combo, within the same box. Now if there was 1 1 1, I can't do this because I can only do 2, 4, 8, 16, and so on. But if it was 1, 1, 1, I can actually make a square. All right? So that's how it works. So now this, the way you want to read your Karnaugh map is you want to see within this box what changes and what doesn't. Now you see within this box, if I go from this section to this section, my y changes. Here's 0 and here's 1. Right? But if I go on the x, you see here x is 1, here x is also 1. So we can see that these two inputs don't even depend on y, it's just x. So now we simplify this expression to just x. Oops, x. Now how can we confirm this works? Let's see. If we take this expression, and we plug in x0 and y0, x0 and y0, this will return false. x0, y, so this what this says, when you have x, this wants a 1, and when you have x prime, this wants a 0. And that's the same thing for the y. Y equals 1, y prime equals 0. And so the combination that will go into here, I shall just keep this for people to see. All right. And so the way it works is x is 0, y is 0. That means, so remember, y prime equals 0, x prime equals 0. In order for this to return true, I'll need x prime, y prime. Do I have that here? No. And that's why it gives me 0. Same thing here. X is 0, so that's x prime, y. Do I have x prime, y? No. That doesn't work. Now again, x, y. This is x, and y is 0, that's y prime. Does that give me a 1? Well, do I have that in this expression? Yes, I have x and y prime. That is a 1. Now if I do the same thing again, I have xy, so xy, and that's right here, xy. Gives me 1, which is valid, right? Now let's do it for the x. This says, well, we know we don't have a y, so we're not even going to read this, because like we don't even have that here. We're only going to read the x. Now this says x. That's x naught. Does that pass? No, it gives me 0, right? Now again, this is x naught. Obviously we have just an x, gives me a 0. This is just x. That's just x, gives me a 1. It's also just x. That's just x, gives me a 1. You see, it works. Now we simplified this whole expression to just x, and we deleted a whole input. And so that's the beauty of Karnaugh maps. They just optimize your tables. Now doing a 3-variable Karnaugh map is basically the same. The only difference is the way you set it up. And so here you want to read it from left to right. And so I have xy. You can only put combos of 2 on one section of line. You can't do x, y, z, and you can put a v here. You can't do this. If it's 3 variables, you do x, y, and then z on the other side. Or you can do x, y, z on this side. Both ways work. All right? And now that's why we're reading it from left to right. X and y go together, and then z is alone. If z was another letter here, it would go z, z, b, let's say, right? But now we only have 3, and so make my Karnaugh map, and there you go. And now, how do you read this? How do you set it up? Well, we know z can only be either 0 or 1. 0, 1. Now these are 2 variables. How do you put them in here? So the way you'd put them is they will take 4 sections, and their combo, what you'll do is 0, 0, right? So it's both zeros, 0, 1, 1, 1, 1, 0. Just remember this, don't forget it. This is the order you go in. 0, 0, 0, 1, 1, 1, 1, 0. And this is my x, this is my y, this is my x, this is my y, this is my x, this is my y, this is my x, this is my y. Alright? Now, if I want to fill in the table, what I'll read is 0, 0, 0. So that's here, right? Because I have 0 and 0, 0. So that will go 0. And then my xy is 0, 0. So that's still this column. But my z is 1. That's here. That gives me a 1. Now I have x0, which is I'm still in the right column. But my y is 1. That's this column. My z is 0. That's this box. That'll be 0. And then my z is 1. This is 1. Right? And again, x is 1. And y and z is 0. So that's this. And so that'll go 0. And then what I like to do is only read the ones. So this is x, z. What I look for, x, z. Where? X is 1, z is 1. There you go. And that would give me 0. Then I have xy. That's xy. But z is 1. So I go up here. 1. Now I have xyz. That's xy, z. 1. Alright? Now how can I write this? Remember how I said we can't select it diagonally? You can only select it when it's like adjacent to each other. So if this was a 1, I could do like this. But you can never like curve. Alright? And so the way we can select this, we can either go like this and like this. Now you'll think, oh, well, can we also go like this? Yes, you can. But this is inefficient since we already have these ones in a box. You don't want to redo them. You never want to redo your numbers, right? And so this is efficient. Now what's another combo you could make? I guess there's no another combo. Now if you want to read this, right? This box, where does the number stay? Now my y changes between 0 and 1. That's oscillates. I don't want that. That's not good. So it doesn't depend on y. Because if I go between these two, it doesn't even depend on y. But my x stays the same, and my z stays the same. And so this depends on x and z. But remember, my x is a 0, so this is x naught, z. Now this box, you see, if I go between here, my z changes. It goes from 0 to 1. 0, 1, 0, 1. Right? And so it doesn't depend on z. My x, however, my x and y stays the same if I go here. And so that depends on x and y. Now, what does it mean when you have xy? And what does it mean when you have x plus y? xy, when you multiply them, that means and. That means x and y have to pass. X has to be 1 and y has to be 1 for this to pass. This says x or y. So if I have 1, 0, well, x is 1, so that passes. They don't both have to be 1. So I can also have 0, 1. That passes. It's one or the other. Alright? And so what I'm saying here in this expression, actually I'm not going to delete that, fuck it. What I'm saying in this expression is I'm saying this can either go with x and y or z not x not z. That's what I'm saying. It's this expression or this expression. Alright, and you see now we simplified this whole expression with only these two. And that's a good thing. And you might even be able to simplify even more with a Boolean expression, but I don't know. Now, how can you fill the table for a 4-variable Karnaugh map? And this is, you see, they don't give us the input. This is one of the activities in the lecture for Rapo's lectures. And so how do you fill this? What you want to read, the way you want to read it is, well, here this is 0, 0, 0, 0, which means, oops, what happened here? Oh, I didn't realize I have one more here. Should we do this one? Nah. All right. You see, the one you want to read it, you have 0, 0, you have 0, 0, 0, 0, and obviously the way you want to read this is not, right? Because they're all zeros. And so, do I have not? Yes. So that's A1. Okay? Now read it again. What do we have? We have not 1. So do we have A, B, C knots and then D? A, B, C knots. I don't see them. So that's A0. And so basically, you just keep doing this. And I have not 1 not. And so if I'm doing it, I have not 1 not. Do I have this? There it is. Not. And then this is 1. And then there's another not. So that's A1. So you basically just want to keep going like this until you find all the combos. So I filled it in to give us some time. And so now, to make the Karnaugh map, what you want to do is do your little diagonal line. And you want to read it from left to right. And so to not confuse you with these knots, let me get rid of them. And what I want to do here is I'll read it from left to right. So I have A, B, C, D. So A, B, C, D. Now if you do it like A, B, C, D like this, that's fine. You'll get a slightly different looking answer, but it's still right. Okay, so keep that in mind. You'll get a different answer, but it will still be right. Okay, but I'm gonna write it just like the profs, just so you can confirm your answers. All right, and so now making a square. Before I make the square, I like to put my inputs. So I get 0, 0, 0, 1, 1, 1, 1, 0. And again, 0, 0, 0, 1, 1, 1, and then 1, 0. Right? So this is my C. This row is my C. This row is my D. And here I have A, B, A, B, A, B, and A, B. Right? Now I can make my square. There you go. Okay, and now all I gotta do is just draw my columns. That is a retarded looking column, not gonna lie. That reminds me of someone's forehead. Look how uneven it is. Alright, so now if I want to fill this in, obviously back to the table, 0, 0, 0, 0 is 1, and then 0, 0, 0, 1, where D is 1. Where's my D1? This is D1. That's 0. And where's my C1? Only C is 1. That is right here. And that gives me a 1. And then I also have, where is CD? 1. CD right here. And that's a 0. Then I have a B, that's a 1. And so my B is a 1 is right here. And that's a 1. And I have my 0, 1, 0, 1. And so that's BD. So B is 1 here. D is 1. That's a 0. And then I have a 1. B and C. And so B is right here. And C is actually right here. So that's 1. And then I have B, C, D. And so the way I'm reading, by the way, I only read the 1s. I don't read the 0s. So B, C, D. B, this is A, so that's not it. B, C, D. Right? And now I have I have 4 1s, and these are all A. You see, I have 1, 1, 1, 1. And all these is when A is all 1s. And so where's A1s? It's either this column, all 1s, or this column is all 1s. Now, what about my B? Is B 0? B is 0 in all of them. You see, this is basically A, B, B 0 in all of them. And so I can assume that this is 1, 1, 1, 1. And then the last, as you can see, I have my B all 1s. And I have my C 0, 0, 1, 1. And so B is all 1s. So that's here. And that's going to give me 0, 1, 0, 1. And then obviously when my C is 1s, so A1, C1, that's right here. A1, sorry, A1 and then B1. I glitched for a bit. I'm still glitching right now. Jeez, I can't see. You know what? I'm going to just read it from the top bottom. My B is 1 and my C is 0. That's right here. Jesus, that's 0. And then we got B and D. That's right here, and that's a 1. And then we got B and C. So C is 1. And that would be right here, 0 and then 1. Jeez, I lagged there. Oh my god, my brain fried. I might have still got it wrong. Yeah, this is supposed to be the other way. That's what I mean. Sometimes you gotta actually be careful of these. Okay, now when it comes to this, how can you make your squares? Now there's a lot of ways you can make your squares. You see, this is 1. This is 1. But remember, we can actually go through. We can actually go through. And so what you can make it is go through. Oops. That's 4. That's a 4 group. We got that. Now here, you can either make it like this, or you can even make it like this. And you'll still get the right answer, but I'm going to match it with the prof. And so this is what he got. Again, if you do it the other way, you will get the right answer. Maybe it will look a little different, but it's still the same expression. Okay, now reading this, let's start with this square that's isolated. As you can see, when I move from here to here, my A stays 0, but my B changes. So we don't care about B. Now here, if I go from here to here, also my A doesn't change and my B stays the same. My B changes, so B doesn't matter. I know this is A, but A is 0 in both slots, so that's, oops, so that's A not. My B doesn't matter. Now what about my left? See here, my C is 0 and my D is 0. Here, my C is 1 and D is 0. Therefore, my C changes, but my D doesn't. And so D. But remember, my D is 0, so that's a D not. Plus, second square. This is 2, so this should be easy. Remember, if I move from here to here, my AB doesn't change. They're always 1. So that's AB. And then when I move here, you see my C changes from 0 to 1. But my D doesn't change. It's 1, 1. So that's also D. Plus, this, as you can see, when I'm moving along vertically, my A and B doesn't change. So it's A. B is 0. That's B not. Now, if I also move vertically here, you see my C changes and my D changes. So they don't even matter, right? And so that's the expression I have. If I want to write it in a better looking way, AB plus AB not, or I can even do it like this. That means not, right? But I believe the prof uses it like this, so we'll keep it that way. And then I get A, B, D. Okay? And so hopefully, so that's Karnaugh maps. If we want to confirm it, you see we went from all of this to just that. If you want to confirm, you can what do you call it? Put a couple inputs and see if you're right. And so what I can do, I can go here and be like, okay, not. And so when my AB is not, that is one of the expressions. And so that gives me 1. When everything is not, but D is 1, do I have everything not, but D is 1? No. You see, this has to be all true, so that doesn't work. And so this is 0. And see, just going off this, you can see that's right. You can, let's choose something random like here. A is yes, CD is yes. So do I have A yes and CD is yes? So I have A is yes, B is not. So that's A is yes, B is not. So that also actually gives us 1. Now I have CD. Now, does that matter? Well, as we can see in our expression, C doesn't even matter. And so we scratch this whole thing, this whole row out because it doesn't even matter. Now I have BD. Is that one of them? No. But obviously, this runs because of this first expression. And so that makes it into a 1. And that confirms our answer. This is also a 1. And so you see, that's how you do Karnaugh maps. Hopefully it helped. If you want to do this as an exercise.